Hi everyone, welcome to Heat Transfer course. I first of all appreciate your interest to attend this YouTube GATE classes, which is an initiative by TEQIP faculty with the motive of Let's Crack the Gate. I myself, Mohammed Rafi, one among the TEQIP faculty from Assam Engineering College. I have done my MTech in Fluid and Thermal Engineering from IIT Guwahati and BTech in Mechanical Engineering from College of Engineering Trivandrum. I basically hails from Kerala and I have been teaching as an assistant professor in Assam Engineering College in the Department of Mechanical Engineering, and I have 4+ years of teaching experience. So being from fluid and thermal science field, I am very much interested to learn and share my knowledge in the field of thermal engineering, especially heat and mass transfer. So in this course, we will be discussing heat transfer, mainly focusing on the GATE syllabus. So I hope you guys may be from mechanical engineering or production engineering or chemical engineering. So like I said, this is a initiative by TEQIP faculty, and we are working remotely from different parts of the country, and we are trying to help, support, assist the fellow students to crack the GATE exam with our experience. So we have been associated with the different institute, different parts of the country. So I hope this course heat transfer also will be beneficial for everyone. So, and I hope we will have a better interaction, and I will be very happy to help you. So I will be sharing my email ID and WhatsApp number at the end of this lecture. And today's lecture, I will be briefly talking about the relevance of heat transfer in GATE or any other competitive exam, as well as I will give a small introduction about the different modes of heat transfer. And in the upcoming classes, I will be talking different modes of heat transfer or critical radius of insulation, analysis of fin or unsteady heat transfer one by one. Okay, so please share this thing, the YouTube link with your friends or other people, so that our effort will be beneficial for everyone. And please stick to the in this YouTube channel. So we will be uploading different course content. I hope you are already watching the other course content, especially casting and manufacturing science courses, which is already uploaded in this channel. Okay, now let's move on to the slides. So before starting the heat transfer, let's try to understand what is a heat transfer or what is a heat. So heat is a form of energy. What is the energy? Energy is the ability to do some work. So in our day-to-day life, we are utilizing this heat energy to achieve a lot of work, a lot of purposes. In our day-to-day life, we are coming across heat transfer in different occasions. And you know that in our world is facing the pandemic challenge, so there are a lot of relevance of this subject. And in this course, throughout this course, we will be trying to share the experience, the industrial or academic experience we have learned related to the heat transfer. And I hope we are focusing on the GATE syllabus, so I hope it will be helpful for you to achieve your career goals. Okay, so basically, like I hope you might be from mechanical or chemical or production science engineering field, so you might have a basic understanding in fluid mechanics, thermodynamics or engineering mathematics. Even if you don't have much idea, I will be recalling whatever necessary theory related to this for the benefit of better understanding this subject. So first of all, temperature. Temperature is a degree of hotness or coldness of a body that you already learned in thermodynamics. But temperature, even though it is talking about the degree of hotness or coldness of a body, now you will be we will be excited to know that it is completely a relative terminology. That means same body which you will term it as a hot body can be called it as a cold body on different occasion. How it is possible? It is always related to the surrounding temperature. Whether it is kept in a cold ambience or a hot ambience, the same body can be termed as a hot or cold body. It is easily understood. Suppose in throughout our course, many occasions I will be taking our human body as a perfect example. So for this purpose also you can get to know. Suppose our body temperature is at 37 degrees Celsius. Now you visit Kashmir or Tawang in Arunachal Pradesh, which is comparably a very low temperature area, which is ambient temperature maybe of -5 degrees Celsius or something like that. So if you visit there, your body temperature is what? 37. Ambient temperature is what? -5. Now the heat will be flowing from where to where? From your hot body to cold body. Is it so? Yes, your heat is flowing from your body to outside. In order to protect yourself, what you will do? You will wear a blanket or some jacket or something like that. The same human being, same body, if we are visiting to Rajasthan, one of the hot place in our country. Now, if you are visiting Rajasthan during summer, the ambient temperature is 50 degrees Celsius. Same human body, okay, 37 degrees Celsius. Now, under 50 degrees Celsius, from ambient to your body, heat will be starting to flow. In order to maintain the uniform body temperature, what you will do? Either you will sit under AC or under fan, or you will be trying to remove your cloth and you will try to improve the heat transfer rate. So that basically the same body which will be working as a cold body under cold situation, hot body under hot ambience. Okay, so this is the relevance. Now here you might have observed one thing. The same body acting as a hot body or cold body depends on the surrounding temperature. Now you can see it is always about a heat interaction between two bodies. One is hot body, another is cold body. So how this hot body is able to interact heat with the cold body? There should be some basic mechanism. Now in this subject, heat transfer subject, we are going to explore this thing. Okay, so once again, let's have a great interaction throughout this course. So one by one, we will be sharing GATE related general ideas, strategies, everything throughout this course. Now, before going to that, let's, like I said, we are here committed to support you guys for the GATE exam. So for GATE exam, why heat transfer? What is the relevance of the subject called a heat transfer in GATE exam? Now, GATE is an exam, that is Graduate Aptitude Test in Engineering, which is a unique kind of exam. The question paper is set by the IIT teachers with some primary objective. So for a unique kind of exam, you should have a unique strategy. So what is our strategy? GATE is something, if everybody go, GATE will not open. In order to have open or crack or break the GATE, you should have some strategy. So in this slide, I am going to share small strategy how to crack the GATE. So here, compare the thermal science subjects. Throughout mechanical syllabus or mechanical syllabus especially, you have different thermal subjects: heat transfer, thermodynamics, refrigeration, air conditioning, IC, power engineering. Out of all, heat transfer continuously, previous year question paper, every year got a higher weightage. Why? Because it is an application level subject. I am not saying other subject is not relevant, but the thing is that if anybody able to answer the question in heat transfer, by default that student will already know thermodynamics, that student will already know fluid mechanics and engineering mathematics. So like I said, as a strategy, you should prioritize subjects. So in thermal science field, heat transfer got a higher weightage, higher priority. Now we are starting to deliver YouTube lectures for heat transfer in this channel, and next will be upcoming lectures will be followed in the upcoming days. Now what I wanted to say is that as a GATE aspirant, as a desiring student, what you have to do is that you have to prioritize subject one by one. But that doesn't mean other subject is irrelevant. The thing is that you should devote a little more time, you should focus a little more time towards this important subject. What are the important subjects? You can say aptitude, engineering mathematics, heat transfer, theory of machines. All these things got a better weightage, fluid mechanics, like that. So in thermal science, heat transfer got a better weightage. So we are committed to assist you, to help you in the subject heat transfer. Okay, so let's begin with that. Now you might have already studied thermodynamics in the previous semester or somewhere else. So you already know the thermodynamics, where we were talking about the heat, temperature, all these things. Now why again another subject called heat transfer? Let's try to explore and understand the relevance. In thermodynamics, what you were doing throughout our discussion in thermodynamics, we were trying to quantify, or we were trying to analyze some equilibrium state. What is the equilibrium states? That is the body achieving equilibrium with its surrounding, system and surrounding, all these things you have studied in thermodynamics. I will try to explain this slide with a simple example. Let's try to talk about the making of a tea. You may be knowing how to make a tea, right? Now again, come back to the present scenario. We are facing the pandemic. People might be locked down at home. People be locked down at hostel, or you may be stranded at some other places. Wherever you are, food is necessary. You have to cook. Either you have to take help from others. So if hotels and everything are not open, now this is a new normal. Everybody should know some basic understanding about the cooking. So I was also locked up, stranded at some places, and I was managing to cook the food by myself. Now in this course heat transfer, we are going to explore the importance of heat transfer in the cooking. Suppose simply the tea making. How you are making tea? You may be a lover of tea or coffee or boost or Horlicks, complain or anything. Now whatever may be, let's focus on the heat transfer aspect. Suppose you are talking about the tea making. What you will do? You will take a water which will be of ambient temperature, suppose 35 degrees Celsius, and you have to boil it into 100 degrees Celsius. Then you will put tea powder, sugar, and if you are interested you can put some milk, or if you are not a tea lover you can put coffee or whatever may be. Our process is what 35 degrees Celsius water is heated into 100 degrees Celsius. Now where is the heat transfer in this? Before that, where is the thermodynamics in this? What is the process? 35 degrees Celsius of water, suppose 1 liter of water, that means 1 kilogram of water, is heated into 100 degrees Celsius of water. Now, how much heat energy is required? There comes the relevance of thermodynamics. If I am talking two equilibrium states, 100 degrees Celsius water, 35 degrees Celsius of water, how this heat transfer taking place, or how this process is taking place, then you will calculate MC into delta T, that is the heat energy required, right? Now where is the heat transfer in this? In order to make the tea, you have different options. Suppose you are making tea using burning the firewood, or using a gas stove, or using an induction cook, electric induction, or using a microwave. Now you have 4 options. If as a being a mechanical engineering student, somebody asks you which one you will prefer, there comes the relevance of heat transfer. You will prefer depends on your requirement. Suppose you wanted to make the tea in a very fast mode. You want to make the tea in a very fast. Then you will use either induction or microwave, something like that. But you have enough time. You are free. Then you will use burning the firewood because it is comparably cheap. In the economic aspect, the burning the firewood will not cost you much. So thermodynamics were unable to talk which one is better, how fast the heat transfer taking place. Nothing was mentioned. It was always talking heat expressed in terms of joules. But in heat transfer, it will be expressed in watt. What is the unit of heat transfer rate? Yes, watt is the unit of heat transfer. That is heat transfer rate. You are already familiar with the rate, right? We were in plus 1 and plus 2, rate of change of displacement, that was velocity, rate of change of velocity, that was acceleration. So in every rate equation, what we were doing, dividing by time. So heat per time, that is joules per second, that is the unit of heat transfer. What is the unit of heat transfer? Yeah, funny it is. Yeah, what is the unit of heat transfer? What is the unit of heat transfer? Yes, what is the unit of heat transfer? WATT. Now again, a general question. why we were calling joules or why we were calling watt? Why it cannot be the Rafi is the unit of heat transfer or Mohammed is the unit of heat? Why we are using joules or watt? This is the beauty of science, because science is evolved, science is focusing, it is a flexible aspect, because somebody observed this thing, quantity called heat, and they have spent their lifetime to explore the area. So as a respect, we are calling the unit of heat as a joule. Similarly, James Watt, which was inventor of heat engines and had done a lot of other things. So Watt is the unit of heat transfer. Now, like I said, thermodynamics is talking about the equilibrium state and heat transfer talking about the state of system with respect to time. How it is relevant? Suppose making a tea. In making a tea, you are concerned, suppose if you are using firewood, the first second the heat of the water is, the temperature of the water is 35. Now if after 1 minute or after 5 minutes, what is the temperature in firewood? It may be 50 degrees Celsius. But if you are using electric induction, in 5 minutes the temperature may be what? It will be around 90 degrees Celsius. If you are using gas stove, it may be around 70 degrees Celsius. So for different source of heat energy, it is having different heat transfer speed or heat transfer rate. So that is state of system with respect to time is known with the help of heat transfer. And thermodynamics never talk about the speed of change of equilibrium state, but heat transfer gives clear idea. How it is relevant, we are going to discuss in this subject. How it can be give a clear idea about the speed of the heat transfer. So I hope we in our classes we regularly quote the day-to-day life examples, and we will try to correlate this with the theory what we are learning in heat transfer. And throughout this course I personally we are committed towards the GATE course, GATE syllabus, GATE exam. So we will be recalling the previous year question. We continuously we will be giving whatever the questions discussing, mostly it will be from GATE previous year questions, and we will cover all the theory related to the GATE syllabus, and also we will try to conduct some online GATE test series. So this is my humble request. Once again, people are putting a lot of effort, so it will be beneficial. Our primary objective is you guys should be benefited. All the engineering graduates in this country should be benefited. They should not have any drawback. They should not have any lack of education opportunity. So we are committed to provide you quality education. TEQIP, Technical Education Quality Improvement Program, we are already committed towards the quality improvement. We are doing this in our respective colleges. So here this initiative, it will be beneficial to everyone if you can spread this word to others. So please spread this word, share the link with others, and if you are feeling benefited from this course, please subscribe this to channel. Okay, now like I said, GATE is a very unique kind of exam. So every student should have a strategy towards this. So the first step in our strategy is understanding the syllabus. If you don't know the syllabus, you will not be able to crack this GATE. So first of all, you should understand the syllabus. So GATE syllabus here for heat transfer, which is got a higher weightage in thermal science subjects, it divided into this much points. You can see in the slides, the highlighted points are the important areas in the heat transfer. So first of all, modes of heat transfer. Another one is if we will elaborately discuss in the next slide, next class regarding the different modes of heat transfer, and I will be discussing the previous year questions asked in this area. And also in the next class we will start discussing in the one by one, that is conduction, convection and radiation. So first we will talk about the one-dimensional heat conduction, then the applications of one-dimensional heat conduction, that is the heat transfer analysis in fins and heat exchanger analysis. Then convection, that is you can see in the convection thermal boundary layer is going to be discussed. Then different modes of convection is there, that is free convection, forced convection, etc. Then again application of heat convection, that is flow over a flat plate and a flow through a pipe, everything are going to be discussed. And another one is the radiative heat transfer, that is a different mode of heat transfer. So conduction, convection, then radiation. So radiation also you might have seen people are using this thing, radiation also it is very relevant in our day-to-day life. It's a different mode of heat transfer. So there are a lot of theory related to radiation, suppose Stefan Boltzmann law, Wien's displacement law, these all are the thing, and also black and gray surface, view factor, all these things we are going to discuss in the area radiative heat transfer. So in this course I have designed this course with different courses, different lectures, and we will be since it is an introductory class, I am telling you I will be starting with the conduction, then radiation, then convection. All these three modes of heat transfer will be elaborately discussed, and I will be sharing all the previous year questions. We have a very good team who is working towards all the course content and all. So I hope all this effort will be helpful to all of you. Okay. Now again look at this slide. What you can see? Yeah, there are two processes are taking place. One is a heating water in a pot, another is heating a rod. This is I am showing here just to give you an insight about the different modes of heat transfer. Suppose I am talking about this process. What is happening here? I am burning some wood or any material. I am burning, I am trying to convert that chemical energy or whatever stored energy into heat energy. So this heat energy, using the first law of thermodynamics, this heat energy is transmitted or it is transferred, because here it is a higher temperature area. So from this higher temperature to lower temperature, heat will be flowing. So how this is possible? So in order to understand this thing, we already knew heat will be flowing from higher temperature to lower temperature from the thermodynamics, second law of thermodynamics. Now, as an engineer, as a scientific person, we are trying to explore more. Now, you should know that this higher temperature to lower temperature, if you observe closely, you will find that there are different modes of heat transfer. So, we will classify them as radiation, convection, and radiation, convection, and conduction. So how this is possible? This is possible by different idea. Now here you can see the heat is reached to the bottom of the pan. So from this bottom, how heat is moving inside? That is by conduction. So what is a conduction? What is the mechanism in conduction? Now the heat is reached to the bottom of the pan and the water is getting heated up. So water molecule, whoever getting in contact with the water molecule, what they will do? They will absorb the heat energy. If they absorb the heat energy, their density will be going down. So if the density is going down, it will become light. So it will move up. You can see the arrows. It is whatever water molecule is getting heated up, it is moving up. So water molecule which is heavy, which is of higher density, will be moving down. So there will be a circulation of water molecules, thereby a heat transfer taking place. That process is called a convection. Heat transfer by mode of bulk motion of molecules, that is called a convection. Now the water molecule is continuously recirculated, so water is getting heated up, its temperature is getting increased. Now the water become the high temperature body and this handle become the lower temperature. Now how this heat transfer taking place from this high temperature to lower temperature? That is called conduction. Heat transfer through a solid body, that is called conduction. It is a mode of heat transfer without any bulk motion, fluid motion. Understood? Now similarly, if you closely observe this diagram, that is heating a rod. In this heating of the rod, here I hope you can see, I am just give you some insight about the practical applications of heat transfer, practical occasion where the heat transfer taking place, so that you will get a better understanding. Now here also, once I started to burn this firewood, it will become high temperature body and the surrounding will become lower temperature. So like I said, there will be a heat transfer from high temperature to lower temperature. How this will be happening? It will be either radiation or convection, because there will be electromagnetic waves emitted from that high temperature body, so thereby the heating taking place, that is radiation. And there will be some bulk motion, because just like I said in the water in the pan, here also whatever air coming in contact with this, it will be absorbing the heat energy, it will become light, so it will go up. So by the same time heavy air molecule will be going down, so there will be a recirculation, so there will be a bulk motion, that is called convection. Similarly, the rod is coming in contact with the hot body, so this point will become high temperature, this point become low temperature. So how this heat transfer taking place from high temperature to lower temperature, that is called conduction. Now you identified from the observation, we get to know that these three modes of heat transfer taking place in a different manner. There is some differences between these three modes of heat transfer. So this will trigger our interest. This we are going to explore how, if these three are different, what are the differences, what are the basic differences. So the basic differences lies in the mechanism. Now by continuous observation, we happen to know a lot of differences among these three modes of heat transfer. And another important aspect is that there are some governing equations. There are some governing equations which drive this heat transfer process. So as an engineering student, as a mechanical, chemical or production engineering student, we are going to learn the heat transfer process. We are going to understand this heat transfer process by knowing this governing heat laws. Now, as an engineer, I hope you already know thermodynamics, fluid mechanics, engineering, mathematics. Now, how this engineering things works? You guys may be preparing for GATE, or maybe preparing for campus recruitment, or maybe preparing for some state or national level competitive exam. Everywhere, this is my humble request. As an engineering student, you should not restrict your learning process into some particular area. You should have always some multi options. So even though you are preparing for GATE syllabus, I will be keeping some discussions towards your campus recruitment, towards your interviews and all, so that as an engineering student you will have a better understanding in the subject, and also you will have a better interest towards the subject. So in this course, since it is an application level subject and your day-to-day activities are closely related to heat transfer, I, as an educator, as a teacher, I prefer to correlate all these things in these upcoming lectures. Okay, so in these classes, in today's lecture, I am giving just a brief introduction of the syllabus as well as the different modes of heat transfer. In next class, I will be one by one, I will be discussing what is conduction, what is convection, what is radiation, what are the governing equations, what are the other things. Okay, so here you can see basic laws governing heat transfer. First one is the first law of thermodynamics. What was the first law of thermodynamics? It was talking about the conservation of energy. What is the conservation of energy? Energy neither can be created nor be destroyed, but it can transform from one form of another form. Very interesting statement, because this is a basic idea of our life. How by eating a food, how you are getting some energy, how, from where this energy is coming. This is a pure example of conservation of energy. How it is possible? The plant which is cultivated by some farmers or somebody else, and these plants are absorbing heat energy from its surrounding and stored in the different form of maybe in the starch or any other form, and you are conceiving that to your body, and in your body is acting like an engine. It is breaking down this material into, again it is absorbed as different forms of energy, and it is stored in different parts of our body like muscle and all. And once you are trying to move your muscles and all, this energy is utilized, and this is a kind of conservation of energy. It is the form of energy is changing from one point to another, but we are neither creating nor destroying any form of energy. Now, another one is the second law of thermodynamics. This is also very interesting. What are the different statement for the second law of thermodynamics? You have studied? Yeah, you might have studied, or even if you don't know, let's recall it. What are the different statement? Clausius statement and Kelvin Planck's. What is the difference? Basically, there is no difference. Both are talking about the direction of heat transfer process, but they are giving that statement in different manner. We know that in our day-to-day life also we can describe the same thing in different options. We have different options to describe the same activity. Okay, so similarly, second law, there are two statements basically, and the other governing law in heat transfer is the continuity equation. What is a continuity equation? Just like the conservation of energy, there is a conservation of mass also. You cannot distract mass. You cannot kill the mass, or you cannot distract the mass. So conservation of mass, which is closely related to the fluid mechanics. You might have studied continuity equations in your fluid mechanics. We will be recalling this thing during the convection, because convection is a mode of heat transfer where bulk motion is taking place. Now, another one is the Newton's law of motion, which describes the flow of parameter. Newton is also contributed a lot towards the different branches of engineering. So here we are going to recall the Newton's law of motion for describing the flow, and especially in the convection area, flow over a flat plate or flow over inside a pipe. Okay, now another is the heat transfer rate equation. This is very important. Heat transfer rate equation. This is something new we are going to learn. This thing we already studied in our previous year semester or previous year other subjects. But here, heat transfer rate equation. What is the rate equation for convection? What is the rate equation for convection? All these things we are going to learn in the upcoming lecture. Okay, and another one is the empirical relationship. This is also quite interesting. We cannot ignore some parameters in some activity. That what I wanted to convey is that in our day-to-day life activities, there are many factors involved. If you start to eat only food, only rice or only chapati, that is not enough. You will have to collaborate with some other parameters as well. You have to drink some water, you have to breathe some air. All these parameters have different relevance in our activity. Similarly, in heat transfer, understanding the heat transfer process also, there are different parameters involved in the different heat transfer process. So we will be analyzing, or we will be learning about the empirical relationship between these fluid properties. So ultimately, this is the basic discussion about the syllabus of the GATE heat transfer and the different modes of heat transfer that you can see here. Now, in the next class, I will be discussing about the modes of heat transfer. So this is an introductory lecture, and I wanted to give you a small insight about the heat transfer subject, but that is not restricted to the discussion. We will be taking, like, since it is a first class, and since it is the first class, I wanted to give a small introduction about the subject, and please, those who are listening to me, I am pretty sure some of you might have already learned a lot of things from the heat transfer subject, and some of you may be lacking a lot of things in the heat transfer subject. So as an educator, as a teacher, my intention is to consider everyone equally. So in initial classes, in the starting, I will be moving a bit slow. I will be discussing all the minute details related to the subject, but in the upcoming classes, once I have covered the basic foundations, then I will be moving a bit far. So who have already studied the heat transfer thoroughly, or who are just starting to learn the heat transfer from the starting, everybody please stick with the strategy. We are committed to support you, to assist you, to help you. So throughout the course, I will not repeat the same thing again and again. So since it is an introductory, I am just talking here and there, but in the upcoming classes, I will be strictly focusing on the syllabus. So there, once I have covered something, suppose conduction, then I will not recall the conduction theory while I am discussing the applications of conduction, that is analyzing of heat transfer in film or heat exchanger and all. So please watch the videos regularly, stick with the strategy, and try to watch the day I am releasing these videos, so that it will be beneficial for you. And also, like I said, I have provided my email ID and WhatsApp number here. If you have any genuine feedback related to the subject, any query related to the subject, feel free to discuss with me, to contact with me. I will be very happy to help you. I again repeat, this is a TEQIP 3 initiative to spread free education and support for the GATE, with the motive of let's crack the gate. So I again request everyone to support our effort by sharing this video with your family, friends and all, and also your batchmates, so that all will be benefited. Okay, see you on the next class. Thank you.